Zai, a very good morning, everyone. Now, today's tutorial is on the topic called reflection, and on reflection, we'll be specifically talking about invariant points. Okay, so what do you mean by invariant points? Now, invariant points are those points whose coordinates, or in simple language, that is, the values, it remains the same even after reflecting it. Okay, so that means the coordinates does not change even if I reflect it. It could be on the x-axis, could be on the y-axis, it could be anywhere on a certain line, something like that. Okay, let's go ahead and give you an example. Okay, so if you did not understand the statement, doesn't matter. I think with the example it will make it much more clearer. So let's say there is a point at 3 0. Now the same point, I'm reflecting it on the y-axis first. We'll see what happens, what answer do we get. Then the same point we will reflect it on the origin, and then we'll reflect it on the x-axis. So when I reflect your 3 0 on the y-axis, what happens? The y value remains same and the x coordinates, the sign changes. So that means the answer will come out to be minus 3 0. Now in the origin, the sign of both changes. Now 0, mind you, does not have any sign. So 0 is neither a positive, neither a negative. So 0, we write it as it is. So we do not put any sign. Okay, so even if you say the sign of 0 changes, okay, so we'll write it as it is only, because 0 is neither a negative nor a positive. So 3 0. Now if I reflect it on the origin, sign of both changes. So 3 becomes what? It becomes a minus 3 0. Does not have any sign. So 0, we do not write positive, we do not write negative, we write it as it is. Okay, now if I reflect the same point on the x-axis, what's the formula say? On the x-axis, the x value remains same, sign of y changes. So the x value remains same, sign of y changes. 0 is not an sign, we write it as it is. Now if you look carefully, what is happening over here is, when I first reflected it on the y-axis, what is happening? We had 3 0, now we got minus 3 0. So at least what is happening is we are getting a different point, because 3 0, if you want to plot, the 3 0 will be here. 1 2 3, the 3 0 is here. So let's say this is point A, so 3 0 is here, but when I reflect it on the y-axis, what is happening? We are getting a minus 3 0. So we are getting minus 3 0. So that means we are getting a different point. So it is not the same point. Now if I reflect this on the origin also, we are still getting minus 3 0. We are still getting this. But if I reflect 3 0 on the x-axis, what is happening is we are still getting 3 0 as 3 0. We are 3 0. We are getting the same 3 0. So since I reflected this point and we got the same answer, now this is what is called invariant. So that means this point, so this was actually A. So now we got a new point, we can call this as a B. So maybe this is also B, but now over here we got the same value, means we'll still got A. So this point, this is called an invariant point. It's not the answer, huh? It's the point that you are reflecting. Whichever point that you reflect will be called an invariant point. But when I write an invariant point, you can't just write an invariant point, because this invariant means the answer remains the same. That means my coordinates remains the same. But when I check this point on the y-axis, we got a different answer. It's changing. In the origin is also changing. It's only in the x-axis not changing. So when I write A 3 0 is called an invariant point. If I say it's an invariant point, then we have to specifically mention where is it invariant. So we can't just call it invariant point, because invariant means it's not changing, but I saw that it's changing. I saw its over here is also changing. So when I say this A is an invariant point, we have to specifically mention where, means where is it invariant. So we'll have to say A 3 0 is invariant on x-axis. So this, it has to be mentioned. Where is it? Because a point is invariant only on one particular axis, you can say, or one particular line. Later on we'll come to lines also. Okay, so it is not invariant everywhere. So just now we saw this was not invariant in the y-axis, this was not invariant in the origin. So it was invariant, means it remained the same only on the x-axis. So when I call it invariant, you have to specifically mention where. So if you do not write x-axis, means that's an incomplete information, means it's wrong, because we can prove that A 3 0 is not invariant, because if I say reflect this on the y-axis, we're getting a different means it's not invariant. So if I want to write invariant, you have to mention which axis. Okay, so 3 comma 0. So let's give you another example. Let's talk about another example. Let's say if I take another point, let's say 0 comma minus 5, supposing. Now if I reflect this on the, let's say, the y-axis, okay, so if I reflect this on the y-axis, and let's say if I reflect this on the x-axis, and if I reflect this again on the origin also, so all of them I'm reflecting it just like the previous one. I'm reflecting in y origin x, y origin and x. So y-axis, what happens? The y remains same, x changes. So y remains same means that this will remain as it is, x changes, but x is a 0, so sign does not change, so we're getting this. Now what about the x-axis? In x-axis, x same, y changes. So x same, sign of y changes, origin both changes, but 0 is 0 only, and this is minus 5. Now it becomes 5. Now if you look carefully, the 0 comma minus 5, okay, it is changing here. So it has changed here, it has changed here, because it is minus 5, we're getting plus 5 plus 5. But over here, if you look carefully on the y-axis, what is happening? It is remaining the same. So we will say 0 comma minus 5 is invariant in y-axis. Okay, so 0 comma minus 5 is invariant in the y-axis, so we have to specifically mention y-axis. So the conclusion is, if you want to try, you can try later on also with more example. So now the most important thing is, now in the first example I took my y value to be as 0. In the second example, I took my x value to a 0. Now you can take more examples and you can just verify yourself, like 3 comma 0. Let's, if you want, I can give you one more example. So where I'm taking the y value as 0. So instead of 3 comma 0, let's say if I take minus 4 comma 0. Now if I reflect this in the y-axis, what will happen? Y same, x changes, so I'll get a 4 comma 0. So it's not invariant. So if I take minus 4 comma 0, now instead of reflecting the y, I'll take it in the origin. So sign of both changes, so I get 4 comma 0, again not invariant. But if I take minus 4 comma 0 and if I reflect it in the x-axis, so x same, y changes, 0 becomes 0. So just like this, man. So that means I had x, the y value 0, over here also the y value is 0. So it was invariant in the x-axis, so over here also it is invariant in the x-axis. So you can try out more examples. So ultimately what we can say is, whenever you have a point whose x coordinate, not the x, whose y coordinate is 0. So whenever you have a point whose y coordinate is 0, just like 3 comma 0, minus 4 comma 0, 5 comma 0, 6 comma 0, 7 comma 0, anything like that. Okay, so whenever you have the y coordinate 0, and if you want examples, will be like 3 comma 0, 4 comma 0, minus 5 comma 0, minus 8 comma 0, all these points like whose y coordinate is 0, what will happen? It will always be invariant on the x-axis. All these points, if you check, will always be invariant on the x. So just the opposite. If it's y0, it will be invariant on the x-axis. Similarly, if I have, whenever your x coordinate is 0. So if I happen to get a point whose x coordinate is 0, like in this case, my x coordinate was 0, so it remained invariant on the y-axis. So if you want, you can check one more example. So let's say if I take one more example over here of this one, 0 comma minus 5. So x, we are taking the x coordinate as 0. So if I take 0 comma 3, if I reflect this in the x-axis, what will happen? X same, y changes, so I'll get 0 comma minus 3, not invariant. So if I take 0 comma 3, same thing, but if I take it in the origin, the sign of both changes, 0 comma minus 3, again not invariant. But if I take 0 comma 3 and I reflect it in the y-axis, what is happening? Y same, x changes, so x is 0 as it is, y also same, so now it is invariant. So if you check, this had your x 0, it was invariant in the y-axis. This also has your x 0, again it is invariant in the y-axis. So we can ultimately conclude that whenever the x coordinate is 0, like for example, you can say 0 comma 3, 0 comma 4, 0 comma minus 5, 0 comma minus 3, any of these where the x coordinate is 0, it is always invariant on the y axis. So what you can do is, or what you can uh, the way you can remember it is, if it's y coordinate 0, ulta. So y is there, 0, so invariant on x axis. So if x coordinate 0, invariant on the y axis. Okay, but at times you may get certain points where you may not have x 0 as well as y not 0. Okay, like sometimes you may get certain points like a 3, let's say 3 comma 3 comma 2, let's say. Okay, so this has neither x nor y0. So then if I get certain points like this, then how do I know where will it be invariant? Okay, so then for this one, so when you have neither x nor y coordinate as 0, then this kind of point will always be invariant in, you can say rather than writing it this way, I'll just write it this way. Okay, it'll be invariant point on, so the previous one where we had the y0 or the x0, it is invariant only on one particular axis, like either on the x-axis or on the y-axis. It did not have two invariant let's say mirrors or the axis and all. But if I have a point, let's say like this, where neither x nor y is 0, then it is invariant on two platforms, you can say, on two lines, you can say. Okay, so it'll be invariant on not the x-axis, not the y-axis, but it will be invariant on line. So you just check what is the value of x. So if it's x, so first what you can do, only focus on the x value. So whatever is the x coordinate, you will say it is invariant on the line x equals to 3. I'll show you this also, how is it invariant. And the second, now focus on the y. So what is y? 2. So it will be invariant on the line y is equal to 2. So the same point, now if it's neither x0 nor y0, then it will be invariant on two different things. It will be invariant on whatever is the value of x, it will be invariant on line x equal to 3, and whatever is the value of y, it will be invariant on line y is equal to 2. Right, so whenever we have a line x equals to 3, now if you are reflecting this on the line x equal to 3, we know the formula is what? We have minus x plus 2a comma y. That's the formula. And if it's y is equal to 2, we have the formula as x comma minus y plus 2a. I hope everyone knows this formula. Okay, if you not know, just have a look at the previous tutorial. We have discussed what will be the formula when you're reflecting a certain point on either line x equals to something or line y is equal to something. That's the formula by which we can get the answer. Okay, and then so first is we have 3 comma 2. So in 3 comma 2, that 3 is my x value, 2 is my y value, and if I'm focusing on this, this is what is called your a, and over here if I'm looking at this is also called your a. So for this one, this is my a, for this one, this is my a, and the x and y is the same for both. So it says minus x, so it says x is 3, so we have minus 3 plus 2, and what is a over here? 3, comma y is how much? Y is 2. Okay, x is 3 plus 2 is 2, a over here is a 3, and y over here is a 2. And then what do we get? We get minus 3 plus 3 to the 6 comma 2. So we get minus 3 plus 6, we get 3 comma 2. So it was 3 comma 2, we are still getting 3 comma 2. So that means a 3 comma 2 is first invariant on the line x equal to 3, because why? When I reflected this point on the line x equal to 3, I got the same value, that is 3 comma 2. Now let's check in the y is equal to 2. Now the same thing, x is equal to 3. Now minus y means minus 2 plus 2, and what is a over here? It's a 2. So we get what? 3 comma minus 2 plus 4. We get 3 comma minus 2 plus 4 is a 2. So we're still getting the same thing. So a 3 comma 2 is, as I proved, is invariant. First, it's invariant in the line x equal to 3, and it's also invariant in the line y is equal to 2. So that means if I do not have the x nor the y coordinate as 0, so that means it will be invariant on two different lines. Whereas if I have my x coordinate as 0 or my y coordinate as 0, then it will be only invariant on one particular thing, that is either it will be on the x-axis or it will be on the y-axis. Now sometimes, as we already know, x-axis is also written sometimes as line y is equal to 0, so they can try to they may say this also, it's still the same thing, and everyone knows y-axis means it is line x equals to 0. Okay, so that we have already discussed. So if I say, then if I have another point, let's say b 5 comma 4, which does not have x nor y equal to 0, then if I say where is it invariant, obviously this will be invariant on first 5 is there, so x is 5, so line x equals to 5, and I see y is equal to 4, so I can say line y is equal to 4. So that means this point is invariant on either line x equals to 5 or line y is equal to 5. If you want, you can verify it yourself by using the respective formulas. Okay, so that is the only thing that we have about invariant points. And in case if you have any questions, any queries, you can always let me know, and then wherever you have doubts, wherever you have queries, I'll try and see what more can be informed about those things to you all. How can I make it more simple for you all? Okay, so that's it for the time being. Thank you very much.